Hey my colleagues, this is softwareing and I'm Ludman. Today I come back with another tutorial on how can you do a fracture analysis by using ansys workbench. So as you know, fracture is the mode of material failures. So this failure is due to the crack propagation. So if the material have the material has all material have initial crack by its nature, no any material free of flaw. So that initial crack will propagate up to the critical crack. So in such case, there are some fracture mechanics parameters. So in this video, I will show you how can you characterize its fracture mechanics parameter of the simply supported steel structural steel beam. So as you see from the problem description, steel cantilever beam laminated with 2 mm depth aluminum foil is required to be tested so as to characterize the fracture mechanics parameters. So adhesive materials whose properties are given on the table here: critical, mode 1, mode 2 and mode 3 energy release rates are given. So this property is added to the aluminum part. So assume that the cantilever beam is a finitely long structures and consider that 10% of the top surface of the aluminum foil is displaced to half millimeter displacement, and hence the crack is initiated at the crack tip, which is also at the distance of 10% along the contact edge of the surface of the two materials. So the crack tip is 5 millimeter from the left end of the beam, and 10% of the bottom surface of an enormous structure is fixed to a support. So in this analysis we conduct a two-dimensional analysis, that is a plane strain condition of fracture mechanics for the portion of the double cantilever beam shown in the diagram. So at the end we have to determine the energy release rate using virtual crack closure techniques. And after that we have to extract the total deformation, the reaction force, and also we will plot the total reaction force versus the deformation curve. So to start with, what I have to do is just we have to open a static structure. So once the static structure is open, we have to adjust our engineering data. So from the engineering data, there are two materials are required. The first one is steel and the second one is an aluminum alloy. So from aluminum alloy we have to add some adhesive property. So from aluminum alloy we have to add the linear fracture criteria here. So the critical mode 1 energy release rates, mode 2, mode 3 energy release rates are added here. So after adjust our engineering data, we have to proceed to our project. So from the geometry we have to change the analysis type from 3-dimensional to 2-dimensional. Since it is a tutorial session, we have to follow all the steps. So we have to change our analysis type from 3D to 2D. So after that we have to proceed our geometry. So to start with, we have to adjust our units. So the dimensions are in meters, so millimeter is our unit. So after that let us select one plane and make it normal 2. After that we have to start our sketch. So let us create 2 rectangles, and we have to create surface by using those sketches. Let us dimension it. The length of the beam is the length of the beam is 50 mm. The upper part, the aluminum part, is 2 mm, and the steel structure is 5 mm. Let us generate. So after that, what we have to do is just we have to create surface from the concept. We have to create surface from sketches. So let us select the sketch, and from operation we have to change add frozen from add material, and the thickness is 2 mm. Now we create 2 different surface from sketch, 2 different sets. So after creating the surface, what we have to do, we have to split the edges we have to split the edges because at the lower end there is a fixed support here and there is a displacement support on the top on the top portion of the beam, and also there is a crack tip around here. So there is the initial crack 10% of the length of the beam, that means 10 millimeter from the left end. So we have to split all those edges. So let us suppress one body and let us split the edges. Yeah, here. So let us do the reverse one and suppress this and suppress. After splitting all the edges, we just create, yeah, so we properly split 10% from the left end. So we finished the design molder, so we have to proceed to modeling stage. So we have to get into the modeling stage. Once the modeling stage is open, we have to check our materials. So we have to change to a plane strain condition. So this is structural steel, and this one is an aluminum alloy. So we have to select our material. So if you see, there is an aluminum alloy structure here, and after that we have to change the mesh type from the program control to the linear mesh. Let us change it. So if you generate this, we simply observe a linear mesh. So we create two different surfaces. The first one is an aluminum, and the second one structure. So they are not connected; they are different surface. So we have to connect them. So to do that, press this connection, and from the connection, contact open region. So from here we have to one is contact and the other is target. So we have to connect the two surfaces. So to do that, we have to select one edge as a contact and the remaining as a target. So we are selecting the lower surface of upper edge. So yes, and on the target we have to select the upper part, the lower edge, apply. So we are connecting the two surfaces from the crack tip to the right end. So starting from the crack tip to the left end, it is free, it's not connected. So there is initial crack length amount of 5 millimeter. So after that we have to create by holding a vertex, we have to create local coordinate here. So create coordinates, we create a coordinate here, and also from the crack tip we have to create some nodal name selection. So say okay. So from here from section we have to create a named selection. yeah, named selection. Here after that, what we have to do is just applying the sizing. So around the crack tip there is some finer mesh, so to do that we have to say from mesh insert sizing. Before that, let us suppress one part. Let us suppress the surface body for the time now, and let us insert sizing. So from here, let us select, yeah, so let us take as a half radius of the sphere and the element size as 0.1, and also let us do the reverse one. Let us unsuppress this body and suppress the upper one. Similarly, let us suppress it again. Sizing, and let us select, yes, here it is, and 0.5 sphere radius and 0.1 edge element size. So if you unsuppress this one and generate our mesh, yeah, so this is a crack tip. So around the crack tip there is a finer mesh. So we are analyzing the fracture mechanics parameter around here. So to do that, press the model and we have to add fracture. So this fracture analysis requires a pre-meshed crack. Let us add this, and let us pre-meshed crack requires a named selection. Let us select this. So after this, what we have to do is just apply a fixed support and fixed support at, let us hold an edge. Let us select this edge. So this is fixed support is applied here, and again we have to apply the displacement at this point. So in the x there is no any displacement, in the y half millimeter displacement is given. After that, on the solution stage, we have to add a fracture tools. So this fracture tools requires crack selection, so we have to select the pre-meshed crack. So this pre-meshed crack is necessary for fracture analysis. And after that, what we have to do is just applying putting all the results by using virtual method. So let us add all the four result parameters. After that, we intend to calculate the total deformation and also the reaction force from the probe reaction force. So this reaction force requires boundary condition. So let us select the fixed support. So if you solve, you can get all the results. So there are some messages. To eliminate those messages, let us change this result, the time to result set. Time to result set. So after that, let us evaluate all results again. The four results will be like this. Those are the 5 results, and if you want to see the total deformation will be like this. If you want to animate, And also if you want to see the reaction force will be in the downward direction. So from the problem, it requires to plot the total deformation, the total reaction force to the total deformation. So select the two results. Then from here, new chart and table, you can plot by simply the software simply plot the graph. So this graph is the reaction force versus the deformation. So this is how can you do a fractional analysis by using ANSYS workbench. So by the way, it's not the only approach, so you can further explore and use another methodology. This is all what I have in this video, so thanks for watching. If you get interesting, or if you want to get some more updates, new updates, please subscribe my channel. Thanks for watching me.